Hi everybody, welcome to Circuits as Crayons, Paper Meets Electronics as a Medium for Creative Expression. My name is Ji Chi and I am the co-founder and creative director of Chibitronics, which produces tools and resources for blending papercraft with electronics. And this all kind of came out of my PhD research at the MIT Media Lab, where I was looking at how do we create tools to enable more people to use technology as an expressive medium so that we can all become technology creators and not just technology consumers. Where all this comes from, for me, is creating a sense of wonder in ourselves and in those around us. So, what is wonder? According to Jane Bennett, wonder is this feeling of being struck and shaken, surprised by the extraordinary that lives amid the familiar and everyday. And when we experience wonder, we see that there's more to the world than we thought, and there's more possibility than we thought. For me, this wonder comes from taking ordinary materials like paper and adding interactivity using technology. Really, really wonderful about combining these two together is that you get the expressivity of the craft, the arts, the paper, with the interactivity of the electronics. You give it meaning as well as life. How I kind of got started in all of this was early on, I created a pop-up book called Electronic Poppables that has sensors and elements made out of paper. And so it started out as an assignment. My advisor told me, hey, I want you to make some sensors out of paper. And I was like, okay. So I started playing around with these different materials like conductive paints and inks, conductive fabrics, and I was making buttons and switches kind of like the ones we see in our keyboard, little squares that you can press on to turn a light. But halfway through, I realized, hey, if I'm making my own buttons and switches out of paper, they don't have to look like squares and circles. They can look like anything. And so I started making flower scenes and skylines and a solar system. And it was really, really empowering to see, like, wow, I love paper craft, but it's going to a whole new level when I can add these lights and sensors. Likewise, all the electronics that I was learning suddenly became interesting and meaningful when I could personalize it through creating these interactive scenes. This next project is an interactive dandelion painting, and how it works is we have a traditional Chinese ink painting of a dandelion field, but the petals are actually made out of LEDs. So first the flowers start out with yellow petals, and then over time they turn into white puffs. And these white puffs are interactive. You can blow on them just like you would a regular dandelion. When you blow on them, the seeds disperse, and these start out new flowers, which then you can eventually blow on too. And what is really fun about this project is not only can the painting be expressive, but so can the circuitry. And so if you look below, you'll see that I created these lines of copper tape, that's the lines in the circuitry, to follow the contours of the painting so that it's also kind of this abstract graphic image as well as being a functional circuit. What's also really meaningful about this piece for me is that it was inspired by two scientists, actually, Jessie Thompson and Zach Berta. Jessie had a background in plants, so she wanted to create a project that was plant themed. And when we introduced the idea of a sensor that can sense blowing, she was like, oh, dandelions can sense blowing. And so she made this beautiful poster, and that went on to inspire this piece. And what's special about this is that it shows that as we introduce more diverse minds to creating with technology, we start to see projects like this that wouldn't otherwise exist. And so that's why I'm really excited about sharing all this with you to see what ideas you and your students can come up with. One thing I want to remind everyone is that you don't need to make something complicated to make something meaningful. So this card is a simple LED circuit with two red lights and a pressure sensor. The harder you press on the pressure sensor, the brighter the red lights will glow. When you close the card, it's actually a puppy, where when you give it some love, it blushes to show that it likes you right back. And so it's a really simple circuit with a pretty simple drawing, but it has a whole new meaning now when you put them together. The technology is important, but so is the story. Sometimes we can get lost giving more attention to how technical something is. And so I want to share that the story, the context, and your characters are just as important as how complex the circuit is that you make. I first started making paper circuits about 10 years ago, and I'm still creating today. And what I found is that it's so fun that a lot of other people enjoy it too. And so I've taught workshops to engineers, to college students, elementary school students, and teachers, and even professional paper artists. What seems to work really well is that people, no matter what their background is, all kind of understand how to work with paper. And so when we use things like paper and tape and stickers to build circuits, people can use skills that they already have and bring in their own imaginations to what they create. For example, here's a beautiful project that blends art with electricity with poetry, in which middle school students wrote haikus about light and then lit them up. Through these workshops, I've also started making my own tools for making paper circuitry more accessible, like these stickers that are actually circuit components. So these stickers are actually functional electronic pieces that when you stick them down to your circuit, they turn on. So now you can use a material like conductive copper tape as your wire and then stick the sticker down, you add a battery, and then the circuit works. And then afterwards you can decorate your circuit, draw in it, and decorate it as if it was another paper craft. As an educator, I believe that it's important not only to provide the tools, but also provide support resources and inspiration. That's why I wrote the Circuit Sticker Sketchbook. This book has activities that show you both how to build the circuitry, as well as how they work. Let's take a look inside. Each activity starts with showing you how to build a circuit using the template, so it's a little bit like a coloring book for electronics. And then the next page is a drawing that allows you to complete the scene. So what does your circuit do? You can draw whatever you want. After learning how to make a simple LED circuit, you learn how to turn on more lights using a parallel circuit. Add interactivity to your page by making a paper switch, so when you press the button, something happens. And making a blinking slide switch so you can have blinking effects. And finally, you can make a pressure sensor so that the harder you press, the brighter the light is, and you can create gentle fade effects. After each guided template and drawing activity, there's space for students to design their own circuits. This way they can practice what they learned and make the book their own. The idea is that once students complete the entire book, they've practiced creating all different kinds of circuits, and they also have a reference to look back at when they're trying to design their own projects. We want to make our resources as accessible as possible to all educators, so we've decided to publish everything under Creative Commons licenses. So if you want to check out the Circuit Sketchbook, you can go ahead and download it for free at chibitronics.com/templates. You can also remix our stuff and create your own sketchbooks. We'd love to see what you make. To get the circuit stickers and other paper circuit supplies, you can go to chibitronics.com. Using only the circuits presented in this sketchbook, you can already do tons of really cool projects. Let's take a look at some examples. These are some jewelry prototypes by artist Yael Friedman. For example, she used the copper tape and used it as decoration in this bracelet and necklace set. She also played with using light to illuminate shadows and textures in the paper that you wouldn't see otherwise, as well as using different colored LEDs to change the mood of a particular piece. Another really awesome piece is this painting by Kei-Fai Steele, who is a children's book illustrator. She created a scene where a puppy is so overrun by ticks that they create an entire city on its back. And this is why it's called Tiki Town. So when you pet the puppy, it actually lights up the windows in the city. And when the windows light up, you can see what the characters are doing. And this is because when the light shines, it illuminates the back of the paper, a little bit like lighting up shadow puppets, which is a really cool technique for telling stories. Once your students are comfortable building and creating with circuits, they can use these same skills to learn to program and add even more interactivity, like making blinking light patterns, making animations, or making their projects interact with sensors. To help, we've created the Love to Code Kit, which is designed specifically for programming with paper circuits. First, there's a programmable clip. When you clip it to your circuit, the program on the clip will control the lights on the page. In this video, we've seen one clip and one program control a light bulb and create a shooting star animation behind the sailboat, and later you can make even more complex circuits, like creating snow falling down. We've learned from working with teachers that it's important to be able to reuse tools, so we chose to use a clip so that you can clip it to many different projects. It allows you to also use the same code or the same program to create different types of scenes by changing up the circuitry or even changing up your drawing. This is especially useful when you're working on a budget so that one clip can be reused between many different students. In addition to making it reusable, we also made our clip more accessible by making it programmable by sound. What this means is that any device that can play music can be used to program your clip. So rather than using an expensive computer or laptop, you can also use your phone or a tablet. Even a record player can be used to program the clip. To write your program, you don't have to download or install any software, you just have to go to our website. We've created various editors based on whatever language you like. For example, if you already know how to use Arduino, you can use this language to write your code. We also created a simplified version that's easier to read for beginners. Finally, we have a block-based visual programming language called Microsoft MakeCode. This programming language allows you to drag and drop blocks, like Legos, and click them together to write your program. It even has this awesome simulator on the left that lets you preview what your code does. Just like with the Circuit Sketchbook, we created another book called Love to Code to teach your students how to program. We believe in the power of storytelling, so this book is a blend of a story adventure book along with an activity book. Let's check it out. Hi, I'm Ji Chi. I'm really excited to share my new circuit storybook called Love to Code Volume 1. It's a book where we learn about circuits and programming with our new friends like Fern the Frog and Sammy the Seal. Meet Fern. She's an awesome frog. She loves to make things and write and dance and play. Basically, she likes to create. One day, Fern sees her friends make these really awesome projects that light up and glow and do all sorts of things, and she wants to make things like that too. So she grabs all her stuff, and then she runs happily along. But then she realizes this stuff is really hard, and she gets really frustrated, and she even thinks, hey, maybe this isn't for me. Then her friend Sammy comes up and says, you know, Fern, some of this stuff is really hard, but you don't have to do it by yourself, and it can be really fun too. Let's try it together. Will you come with me? And so Fern brightens at the thought and says, what do I have to lose? So Fern jumps in. As you go through the book with Fern and friends, you'll learn all sorts of cool stuff, like how to build a paper switch and blink an LED. You'll also learn cool programming concepts like if statements and loops and even multi-threading. At the end of the book is a chapter on debugging. This is when you find problems in your code and fix them. It's frustrating sometimes, but don't worry, our good friend Debug will be here to help you. As Fern goes through her adventures, we're all going to learn how to make all sorts of cool stuff with circuits and code. Have fun! As with our Circuit Sticker sketchbook, we've decided to publish the Love to Code book under Creative Commons so that you can check it out for free. Just go to get.chibitronics.com/ltc-vol1.pdf. We'd love to hear what you think. So, if you're ready to get started, you can head over to chibitronics.com where we have all of our tools and supplies for sale, as well as tons of resources for you to get started. In addition to our books and templates, we also have tons of tutorials that show you how to do all the activities in the books, as well as a projects gallery where everyone can submit their projects to inspire others. We also want to support teachers, so we give every educator a 20% discount. Come check it out. There are also tons of other great paper circuit resources out on the web. For example, you can go to Instructables.com and search Chibitronics. The Tinkering Studio at the Exploratorium has a great page on paper circuits. Colleen Graves, who is a rock star librarian, wrote a wonderful book called The Big Book of Makerspace Projects that has tons of good paper circuitry. The Art of Tinkering is one of my favorite books for getting inspirations. For links to these and more, such as great places to order supplies, check out the handout that came with this conference. To see what our community is up to, follow us on Twitter at Chibitronics. We find a lot of teachers like to congregate and discuss there. For inspiration on projects, go to our Instagram feed at Chibitronics. There are tons of beautiful crafted paper circuits there too. Thanks so much for coming to my session, and I hope you enjoyed it. If you have any thoughts or questions, I would love to hear from you. You can find me at info@chibitronics.com, and if you have thoughts for projects or collaborations, I'd love to hear those too. Looking forward to seeing what you all make. Take care.